In the previous episodes we saw that with conventional propulsion-based technologies, humanity will never be able to reach out to the stars. More than 1,000 years ago, the Chinese were already using basic chemical propulsion for their fireworks. We need new ideas now. We want to travel faster than light. One serious proposal for achieving faster-than-light travel was suggested by the Mexican theoretical physicist Miguel Alcubierre in 1994. He was interested in the possibility of whether Star Trek's fictional warp drive could ever be realized. "I was watching Star Trek and thought there must be a way to do this right," he said. But before we can discuss his idea, we need to look at the fabric of space and time. In physics, space-time is any mathematical model that combines space and time into a single continuum. It is usually interpreted with space as existing in 3 dimensions, and time playing the role of a 4th dimension that is of a different sort from the spatial dimensions. In order to understand Alcubierre's idea of traveling faster than light, we need to understand one of space-time's unexpected behaviors. It is warped by matter or energy. What does this mean? As an illustration, let's have a look at a plane in empty space-time like in this picture. For simplification purposes we ignore the z-space dimension. In this scenario a laser beam would travel along a straight line from one point to another on that plane, and multiple clocks located at different areas would all run at the same speed. Now let's look at the same plane when there is some matter placed at its center. What happens now? The plane gets warped like a trampoline. The light travels differently from one point to another, and the clocks at the same location on the z-axis no longer run at the same speed when compared to each other. In fact, the bent plane indicates the areas where the clocks run at the same speed. Let us now imagine a straight line from A to B. Clocks 1, 2 and 3 placed on that imaginary line run slower than the other ones at the borders. In particular, the farther away a clock is from the plane, the slower it runs. So, clock 2 will run slower than 1 and 3. Got it so far? A fact of particular interest is that the light does not follow the shortest path anymore. There is a shorter connection possible, and this brings us back to Alcubierre. Thinking about ways to realize a kind of warp drive led him to search for a valid mathematical description of the gravitational field that would allow a kind of space-time warp to serve as a means of superluminal propulsion. Alcubierre concluded that a warp drive would be feasible if matter could be arranged so as to expand the space-time behind a starship, thus pushing the departure point many light years back, and contract the space-time in front, that is bringing the destination closer, while leaving the starship itself in a locally flat region of space-time bounded by a warp bubble that lay between the 2 distortions. The ship would then surf along in its bubble at an arbitrarily high velocity, pushed forward by the expansion of space-time at its rear and the contraction of it in front. It could travel faster than light without breaking any physical law because, with respect to the space-time inside its warp bubble, it would be at rest. Also, being locally stationary, the starship and its crew would be immune from any devastatingly high accelerations and deaccelerations, obviating the need for inertial dampers, and from relativistic effects such as time dilation, since the passage of time inside the warp bubble would be the same as that outside. Albert Einstein once said, "If you can't explain it simply, you don't understand it well enough." Well, then let us see how Miguel himself explains his own concept.
So the basic idea is you expand space behind you. This actually makes you move further away from those objects behind you, and you contract space in front of you, getting closer to the objects in front of you, but you don't move at all. Assume that this is a spaceship. So normally you would have to fly through space like that, and you cannot do this faster than the speed of light. But instead of that, let us contract space here and expand it here, like this. So you see, now the spaceship is getting closer to this side. and further away from that side, but it's actually not moving at all with respect to the objects around it.
Could such a warp drive be built? It would require, as Alcubierre pointed out, the manipulation of matter with a negative energy density for the backside expansion of space-time. Just before, we saw that matter or energy contracts space-time. But what is negative energy? Currently nobody knows for sure what that is, and if it really exists. Some scientists believe that the accelerating expansion of our universe is caused by this kind of energy. However, in the initial release of his paper, Alcubierre also stated that the amount of energy needed would make such a warp drive impossible to be built. In-depth analysis of Alcubierre's warp drive concept by Chris van den Broek of the Catholic University in Leuven, Belgium, some years later has perhaps brought the construction of the Starship Enterprise a little closer. Van den Broek's calculations put the amount of energy required much lower than that quoted in Alcubierre's paper. Van den Broek concludes, the first warp drive is still a long way off, but maybe it has now become slightly less improbable. Further theoretical progress was reported at the recent 100-year Starship Symposium in Houston, Texas. Harold White of NASA's Johnson Space Center reported that his calculations show that if the warp bubble ring around the spaceship was changed from a flat ring into more of a rounded donut shape, the mass needed to create the bubble drops from that comparable to the planet Jupiter to that of a small spacecraft. Oscillation of the warped space reduces the required mass even more. White and his team are attempting to create micro-warps with lasers in a desktop-size experiment. Though far too small to be useful for a spaceship, proving that such warped regions in space-time can be created at any scale would be revolutionary. Such investigations into warp drive and other shortcuts around the speed of light limit will no doubt go on for many years. This ends our short excursion into interstellar travel. I hope you enjoyed it. The next time we will continue with our regular broadcasts from New Space.
Warp 1, engage!